This video is like the problems on your take-home quiz where you have to find everything. All the x-intercepts, y-intercepts, all the good stuff. So let's start out with the Algebra 2 stuff. So x-intercepts are when y is 0. And there is no way to make this 0, so there are no x-intercepts. Y-intercept is when x is 0. So 0 plus 5 is 5. So the y-intercept is at -4. Right there. Okay, so now let's find the derivative. V u prime, derivative of -20 is 0, minus u v prime all over v squared. And so this is nice, this all is 0. We have -40x plus 40x because of that other negative. So our derivative is 40x over x squared plus 5 squared. Possible in critical numbers are at x equals 0. You can't make the denominator 0 to make it undefined, so we just have x equals 0. So our intervals for our increasing and decreasing check, I need to plug in numbers that are smaller than 0. So any negative number is going to, the denominator is always going to be positive. So any negative number will make that negative. And any positive number is going to make it positive. So I have a relative min at 0. We already found the y-coordinate for that. So the relative minimum is at 0, -5. Now we need to find the second derivative to look at concavity. So I'm going to start out with try to cut out my derivative there, and I'm going to erase this other stuff so you can see me working out. Need to find a faster eraser. Okay, so I have my first derivative. I need to take the second derivative. So y double prime equals v u prime minus u v prime is a chain rule, so 2x squared plus 5 to the first times 2x all over v squared. So I have 40 x squared plus 5 squared. Now this is, to combine here, we have 40x times 2 times 2x, so minus 80, sorry, 160. Going to multiply. X times x is x squared over x squared plus 5. x squared plus 5 to the fourth. I can take an x squared plus 5 out of every term. So this becomes a 1. That goes away. That becomes a 3. So all I have is 40x squared plus 200 plus 160x squared all over, sorry, that's a plus there, yeah. Should be a minus. About screwed it up. Over x squared plus 5 cubed. So that is second derivative final value of negative 120 x squared plus 200 over x squared plus 5 cubed. So I need to look at what makes the numerator and denominator 0. Denominator will never be 0 because the x squared. So the numerator is all I have to worry about solving. So x squared equals 200 over 120. 20/12ths, divide both of them by 4, you get 5/3. So when you take the square root of that, you got to use the plus or minus value. So I clear out a little space here because now we got to check our intervals for concavity. So I have negative infinity to negative radical 5/3. You can't see it. Trust me, it's there. Negative radical 5/3 to 5/3. And radical 5/3 to infinity. Sloppy. Okay, so I'm going to pick a really big negative number to plug in here. And really all I need to do is see if I plug in a big negative number, am I going to get a positive or negative? Well, a big negative number squared is positive times a big negative number. That's going to be negative. So this is concave down. Between these two I need to put in 0. 200, so that's going to be 200 divided by 5 to the third, which is up. And then I put in a really big positive number and I get the same thing as when my negative number is going to be a big negative number. So concave down. So I have inflection points at negative 5/3 and 5/3. So now I have two points there that I gotta find the y coordinate for. So there's my x coordinate. And my x coordinate. And the y coordinate is something you can plug in. I'll let you plug it in if you really want to know what it is. I'm not going to go ahead and find it. I know that radical 5 is close to 2, so this is close to -1 where this happens. So if you have to make a sketch, you know it's concave down to the first one, and then it's concave up between them, and then it's concave down again. So making our sketch, going back to what we knew before, it was negative, it was decreasing somewhere in here, changes to concave up, increasing concave down. If you put that in your calculator, you're going to get some kind of a little function. It's like you You ate too much for dinner. This is your graph.